We're called Terreform. We're a non-profit organization. We're a 501c3. So we convince the IRS that what we do is not exactly architecture for making money, but architecture for philanthropic reasons, for humanitarian reasons. So I'm going to unpack a little bit of some of the work that I do there and what I do with some of my partners. This is a project I did with Dr. Lara Greedon and Javier Urbana, who's soon to be Dr. Javier. We worked on this project thinking about a competition for how we can change the building profession from a building technology point of view. Meaning that in the life cycle analysis of a building, you have to chop down some trees with power tools, put them on trucks that use gasoline, that bring them to a sawmill, that reduce them to elements for construction using more power, then delivered to a site, unpacked again, and used as a building envelope for X amount of years before the entire building is taken down and ends up in a landfill. Well, we're thinking, screw that, let's just grow it on site. Or, let's think about how we can make the architecture actually living and fully integrated into the ecology and edible, at least to some life form somewhere in the spectrum. And it wasn't, the idea which was at first fantasy is absolutely possible. It's been around for 2,500 years. So we are not the inventors of the living treehouse. There's many people who are interested in that. However, our contribution to this wall of knowledge, our brick, is placed in the realm of CNC, or rapid prototyping. In other words, control of tree growth. This you can see here is from the tree circus. This is a 15-year growth of a very strong arch for a tree. This is a lattice system, also of a living tree. This is, I think, also 10, 15 years of growth. And we have some wonderful Israelis that can get this stuff in 3 or 4 months. Using ficus, which is a semi-epiphytic plant that essentially is very soft when it's being grown, especially the root structure. But when you pull it out and expose it to the air, pull the roots out, they want to get hard, right? So what you do is when it's soft, you weave it through some CNC system, right? So here we are plotting out the entire geometry to 7 decimal places of accuracy, and we weave in our soft pieces of ficus or whatever is locally needed. And here's the ficus inside there for those of you who can see. And then you'd start growing out your wall. The wall, right? If you know anything about ficus, right? It doesn't spend all its time making a trunk, right? It doesn't stand on its own. Most of these plants, like lianas, they need to hang on something, right? They're parasitic. But when you give them a geometry and they get a little bit hard, they're gonna be stabilized, especially if they're triangulated. You connect them to a larger structure, like a regular tree, or a tree in an arch, and you've got yourself an envelope. So it's a matter of filling in that envelope. This is the popular science image. God, it's cut. Well, anyway, you get the picture. It's wonderful. And here's a section of it growing. That's an elevation view of the fab tree hab. And we have a developer near Beverly Hills who was just on Home and Garden doing this thing, who wants to build one of these things. But you can't do it because, well, not because of the technology or the time it takes. It's because, have you ever tried to pass one of these through a planning board, right? If there's a 40-foot height limit, my tree or the treehouse is going to hit 50 feet at some point. Also bondable insurance contractors or insurance for details. You can't find a spec writer that's half botanist, half agricultural arboursmith, farmer slash architect that can write these specs to be bondable for an insurance company. So we did the 50% version. This is called Matscape, another project that I worked on with some great folks at MIT. So this is essentially a quilt fitted into the landscape pulled up with some components that are living, then business as usual construction, and then other elements for energy generation like photovoltaic cells or natural ventilation like ETFE foil pillows, and some other device that I worked on at the Media Lab called these wind quills, which generate low voltages for wind. So you get multiple layers of energy generation.